Okay, we come to our final session of today, the Quantum Horizon. Please welcome your panelists to the stage. Ilyas Khan, Jeremy O'Brien, Ekaterina Almask, and your moderator, Chris Bishop.
Hello. Well, you've made it to the end. Hey, delighted you're still here. Fire up my notes. In preparing for the session today, I was thinking about why did Alex and Annabelle put quantum at the very end, and I've decided the reason is they wanted to be, this conversation about quantum to be as close to the future as possible. So here we are, right?
It's very bad.
Very bad. Come on, I thought it was reasonable, no? I have a distinguished panel. I'm going to ask each of them to just introduce themselves in case you don't know who they are. Those of us who've been working in the quantum space are familiar with this lady and these gentlemen, but I want to give them each a minute to just kind of talk about who they are and what they do and what their organization's involved in. Then we'll get into some questions. So, Katja.
Yeah, so I'm a general partner at OpenOcean. We are early stage venture capital out of Helsinki and London. We invest across Europe, and we think about ourselves as about creators of ecosystems. One of the emerging ecosystems is, of course, quantum, and we were very proud backers, early stage backers of IQM out of Finland and Germany. This company has raised quite significant amount of capital and also helping us to create ecosystems here. We continue to, of course, be very big supporters of artificial intelligence. We invest in a lot of hardware and software companies and continue to look for outbreaking unique technologies out of Europe in all these areas.
Great, thank you. Jeremy, tell us about.
Yeah, thanks, Chris. So my name's Jeremy O'Brien. I'm one of the 4 co-founders of PsiQuantum. And prior to founding PsiQuantum in 2015, I was a professor of physics and electrical engineering for forever.
Forever.
And PsiQuantum is a Silicon Valley-based photonic quantum computing company. We're about 300 people, and we've raised of order $1 billion to date, and we're on a path to swiftly delivering a utility-scale system, which I may explain more about in a moment.
Yes, great. And Ilyas.
Yeah, no, thank you, Chris. Pretty bad lame joke, but
oh, come on! I thought it was reasonable.
Yeah, silence from the audience. My name's Ilyas, yeah, and I'm the founder of something called Quantinuum, which is a result of a merger between 2 companies, Cambridge Quantum, which is about 2 weeks away from its 10th anniversary, which, as the name suggests, was a spin-out from the university in Cambridge, and the subsidiary of Honeywell, which was called Honeywell Quantum Solutions. So Quantinuum is a business that is co-located in the United States and in the United Kingdom. We're fully integrated, and if I get the opportunity, will help you to understand what that means. And quite a large number of customers, as well as shareholders, are in this room today, so I'm on my very best behavior.
Great. Just a quick unabashed self-promotion from my side. I'm Chris Bishop. I'm the host of the Quantum Tech Pod. So I don't know if you're aware of that. I just published my 73rd episode. It's on Apple Music and Spotify. Ilyas was a guest a while ago. For those of you new to quantum, I encourage you to check it out. Again, with all lack of modesty, I've spoken to some really brilliant people about what they're doing in the quantum space, including some people in financial services. So that's my plug. And in the spirit of getting you up to speed with what's going on in this space writ large, right? I want to start by asking about what are the main trends in quantum technology that are already affecting financial markets? And Ilyas, I want to start with you. What do you see?
Affecting financial markets?
Yeah.
Specifically?
Well, financial services companies and banks. And
it's a very short answer then.
Oh, come on. Elaborate.
Yeah, so, well, first of all, I think the preoccupation of banks with artificial intelligence, which has been stimulated by the events of the last 2 years, clearly predominates both budgets and share of mind. But there are an increasing number of organizations that have taken the view that over the course of whatever their business plan is, and their business plan might be 2 years to go on this one, and the next one might be 3 to 5 years, quantum technologies will become more important. And there are differing degrees of adoption, which I think are catalyzed by two global trends. The first global trend is that quantum is geopolitical. There's not a country of consequence around the world that doesn't have a quantum plan, and those quantum plans are deep, meaningful, and relevant. And the United States, United Kingdom, for example, Germany, France, Australia, that Jeremy's very familiar with all of those, in fact, affects the way in which national champions, especially in finance, then are either prompted, prodded, pulled, pushed, or sometimes themselves are the puller of resources into this sector. Specifically, JP Morgan, from their balance sheet, invested $100 million in my company. It's a big investment for somebody who has to allocate capital against that investment. And other organizations similarly have decided that it's time to get in, and their investment is either direct into organizations and proof of concepts or indirect into the building of teams. So that's one prompt, which is sort of, let's call it national interest oriented, and where there's a huge amount of government support because governments want their national champions in finance and banking to be quantum aware, quantum ready, etc., etc. The other push is mostly from the because of the advent of concerns about non-deterministic seeds for things that are cybersecurity related, so keys, for example, and the realization that at some point a problem that cannot be completed using a supercomputer, which is the generation of a certain type of randomness, which can then therefore be non-deterministic in the seeding of these keys, will affect what they do. And today, as I was listening, and I don't need to say any more than this, there's something which is immediate, which is an application that's a compute application that can be completed on a quantum computer that has a particular setup. So these are two examples from my perspective, but I would caution that there are many other industries that are far more advanced in their adoption and support of quantum. And Jeremy's one of the founders of a rather stunning company and will have his own perspectives, I'm sure. But by way of disclosure, I am an investor in IQM because I knew Miko when he was an academic, and I chucked in a few pennies when he got going. So I think that the European perspective in finance is very, very, very different from the Asian and the American and the Australasian focus. So I'll stop there.
Yeah. Well, so Katja, from a VC perspective, what are you seeing in terms of quantum and financial services settings?
Well, we are all very excited about the potential of quantum computing as investors and from what we are seeing in the ecosystem. I will throw out a number, and you can believe it or not, but it's claimed by McKinsey, actually, that over 1 trillion in value will be generated because of quantum computing technologies in the next 10 years. Okay, so over 1 trillion. I think exactly saying like 1.3 trillion. And 1 trillion of that will be in the financial and banking. So according to McKinsey, this is by far the sector that will benefit most in the short run. And of course, as investors, what we are looking for is like, what are the use cases that will be most valuable? Right. And we see already now, today, we see use cases that are actually generating value. They are not yet connected to the hardware. And this is a big thing. Like we are developing hardware in quantum computing, but then there is software that is quantum-inspired or whatever you call it. But in quantum-inspired software, we see a real value in portfolio optimization. Like when you have a multi-dimensional, like super large matrix of your portfolio where you need to find really what will be the best decision for the future, considering risks, considering all the inputs from the market, from different players, it's actually very hard to do it on a classical computing system. It's very hard to do it with a classical approach, but in quantum, you can actually accelerate those processes hundreds of times.
Yeah.
And this is why this is again.
So that's a great segue. My next question is, I want to get down into sort of more processes, right? So ideas about what existing processes are being enabled by quantum computing. You mentioned maybe portfolio optimization. Other areas include maybe fraud detection, Monte Carlo simulation, derivative analysis. Are there other?
There are many use cases, but again, so as investors, we are looking what will be in the short run. I'm saying short run is 10 years, because this is our horizon when we invest in technology. So what will be the bringing value in the short run? And cybersecurity, absolutely.
Right.
Both
We'll
sides,
talk
fraud
about
detection.
that in a moment. Yeah,
exactly. So, but maybe we can keep it for.
Yeah. Jeremy, what's your take on sort of existing processes that can be enhanced or that people are investigating?
Yeah, so I think, this is a technology with applications across pretty well every industry, and obviously we're here at an AI conference for the financial industry, and we're the quantum panel, so we'll focus on the financial applications, and the way we think about it and the way we work with customers in this is there's sort of a multitude of phases as we develop ever more capable technology, and so the first phase is in that sort of stochastic modeling and simulation, derivative pricing being an example of that, and then so that's the sort of near term, and then in the midterm, more optimization problems, so portfolio optimization type things, and then in the long term, and this is much more speculative, I want to be very clear on that, machine learning applications, and today no one has an end-to-end recipe for how to use a quantum computer for machine learning applications, but there's good reason for optimism that may play out, and if that optimism does play out, then there's a whole host of further applications there. And just to sort of calibrate for folk here, if we take that derivative pricing, one of those early applications, Goldman Sachs have a paper out there that is in the public domain. Our team, our solutions and applications team have taken a look at it. They think that there's a couple of orders of magnitude improvement that they can make to that, which would mean that it would fit on our earliest systems. So that's an application inside of this decade in this industry. And I think Ilias has already pointed out something that I think is a bit anomalous here. And in fact, we've heard, okay, there's a trillion of value to be created from this technology, a lot of it in this industry. Now you can argue whether it's a trillion or half a trillion, or whether it's 80% or 20%, a lot of value to be created. And Ilias has pointed out that this industry is not yet leaning into it in the way that other industries like the pharmaceutical industry, materials, chemistry, aerospace, automotive, a whole multitude of other industries are. And I think that's hopefully something that we can help with as part of this panel this afternoon.
So I want to talk about a topic that's certainly top of mind for all businesses and definitely for banks, right? And that's Y2Q or Q Day. How many people have heard of Q Day? Anybody, right? So that's the point at which quantum computers can crack RSA and ECC encryption, right? So Shor's algorithm can be factored, and your data, the thread is called harvest now, decrypt later, right? And the idea is that data can be captured and then sold ransomware by non-state actors or competing companies or competing countries or whatever. So certainly implications for banking. So I want to get your take, Ilias, I want to get your take on how can banks and financial services firms deal with that threat? What's your advice?
Oh, well, I don't have any advice, and cybersecurity is not my gig, but I'll make an observation that I think is a prompt for people perhaps to do a bit more research. Up until now, it's been well known that maximal randomness is to be extracted from nature. In fact, I think the Nobel Prize for the Bell test, was it last year, Jeremy, or the year before? Last year, maybe. I think Alan Aspect and those guys, yeah. So very recently, there's been a Nobel Prize for this as well. But the problem there is that if you're extracting randomness of that nature, you need to trust the source from which it's coming. And so from a traditional cybersecurity standpoint, this has been a bit of a challenge. And of course, you need access to a quantum computer that can do these things. And there are a few around that can do these things reliably. However, in 2019, Google championed something that they called quantum supremacy, which was something called random circuit sampling, from which you can derive a benchmark called cross-entropy, which is many orders of magnitude better than anything that is pseudo-random. And we all know why that's important. Now, it took only about a week and a half for, I think, IBM to prove that a supercomputer could do that in 2019. This year, we've crossed that threshold. The cross-entropy benchmark that was achieved, it's in the public domain. We did a project with JP Morgan and with Caltech and the Argonne National Labs. And so this is now product ready. And in fact, JP Morgan are very focused on this. And so this is something that will go into production on the defensive side. And my last point would be that this is not necessarily because you have to be prepared for Q-Day. It is true that a quantum computer would find it difficult, if not impossible, to replicate that particular seed, although there are other things that a quantum computer could still do. It's more about the banking industry, and obviously government and security, have always taken the best on offer. So if the best product on offer cannot be replicated and is therefore non-deterministic, meaning that there's no algorithm involved, people will adopt it. And I think this is a very large market, and it's a matter of time, whether it's later this year or early next year, when this is a product that people can buy without having to invest in a quantum computer. So you buy these boxes already. They're called HSMs, I think. I'm just saying that. I have no idea what an HSM is. I don't even know what the initials stand for. But these are things that Steve here will know. But there are many different approaches, and some organizations are so large and who are highly dependent upon these barriers to protect themselves and their daily operations, that they don't rely on suppliers. They themselves generate that. And of course, large money center banks are in that category. So I would say that that is my contribution, my rather feeble contribution to this particular part of your Q&A, but I would say that you don't have to wait until Q-Day.
Yeah. Katya, what do you think? So, I mean, obviously there are companies that are standing up this kind of capability, including big companies like IBM and smaller companies that kind of go to market in a niche solution approach. Advice for people in financial services or banks around harvest now, decrypt later, that process?
Well, I think the only thing that we are thinking again as investors is that it's better to invest now than to invest later and regret. So our approach, these technologies actually are being developed. We think that the perception sometimes is that quantum is far away. We think that quantum is happening already now. Actually, the problem in quantum today is engineering problem, which is very well described and is solvable. So it's not kind of like science fiction. So it's happening. And we do believe that organizations that don't invest today in capabilities to deal with their quantum world, when quantum computing arrives on a large scale, they will lose big time, whether because of cybersecurity threats or other, disadvantages, even in terms of decision making. So, in our view, developing not only investing in the technical capabilities or hardware or software stack, but also developing talent within the organizations to work with these technologies. I think one of the biggest concerns for us is that we don't have enough people to work with technologies. We can bring whatever wonderful machines to the market, whether it's like quantum or, and bring a continuum software, but if teams cannot work with those systems, it's useless, more or less. And we do expect the industries, whether it's banking or others, but banking, first of all, because of this value to be created there, just to start investing in developing these talents and capabilities internally, which means buying early stage machines, buying the software stacks, and start working with them, start experimenting with them to be prepared for the D-Day or anything else.
Jeremy.
Yeah, maybe just a quick bit of disambiguation for the audience here. So Q-Day is the day at which you have a quantum computer that is powerful enough to decrypt our current encryption standards, so RSA an elliptic curve cryptography that's used by all of you and all of your organizations and pretty well every other organization on the planet. And that's very real and rightly concerning for governments and organizations alike. It requires a quantum computer with millions of qubits, and there's plenty of debate about when exactly that will happen, but my position is it's happening soon, much sooner than people might be planning for.
Yeah.
Again, I'm not an expert on the topic, but as far as I understand, the solution is post-quantum cryptography. So that is cryptography that doesn't rely on anything quantum, but is nevertheless robust to quantum computing decryption. And part of those solutions, as Ilias has alluded to, may rely on true random number generation, which can only happen with quantum systems. So you cannot get random numbers generated from non-quantum systems. And just to highlight that, a minimal quantum random number generator is 1 qubit, and a Q-day capable quantum computer is millions of qubits. So just to put all of that into some sort of context, and then in the middle of all of that is this post-quantum cryptography, which, as I say, is a convention, it's a non-quantum cryptographic protocols that certainly the NSA have for at least a decade been instructing the world to get on with implementing, and indeed governments and corporations are increasingly focused on doing that. The challenge, as I understand it, again, not as an expert, is that whilst those solutions do exist, they're not at the enterprise software level of deployment. Yeah. There are solutions out there that we understand to be robust to quantum computing. And I guess, if you're happy, Chris, I think that's the threat part of this thing for this industry, but I think the opportunity part is far more compelling, because that's, I think the threat part of it is not unique to this industry. It is applicable to everyone who has data that they don't want people decrypting, which is approximately everyone. But derivative pricing, portfolio optimization, some of these optimization, machine learning things that that are specific to this industry.
So, Ilias.
No, I was just going to add to, actually, Jeremy's very prescient in what he just said in terms of the opportunity, but I do think that we've got somebody on the panel here that can speak meaningfully to this. Jeremy, I was just going to say, the parallel track for the last 20-odd years, some of which you were slaving away as a professor, has been this allure and the threat of quantum key distribution systems, which allow organizations to benefit from messaging which cannot be hacked and therefore is maximally safe. And I'm aware that it is not an area of expertise for myself, but a lot of banks have invested, either individually or at the behest of government, in setting up local QKD systems. And I just wonder, Jeremy, whether I know that you said that perhaps the Q-day might be closer. What about your sense of the prevalence and use, therefore, by financial organizations of QKD systems? Do you have a view on that?
Yeah, and you're right. I did work on that for a very long time, and indeed I'm a small co-founder of a quantum communication company, but I don't claim to be an expert these days. But my understanding would be that that may be a solution. So in this case, you secure, you implement communication that is secured by the laws of quantum physics. Whether that is a compelling solution or not, I think is somewhat open. You probably are an investor in multiple of these organizations and know more than me about that, but there's a lot of people out there. They've got customers. Banks are big customers for obvious reasons, and wiring up the City of London, for example, is one such application domain. But of course, security, there's no security guaranteed by the laws of physics, which is often the misnomer of QKD. There's a component of it that is guaranteed, but it's an end-to-end system that's used by humans at either end. So I hope you all appreciate the laws of physics will not guarantee the security of anything that humans are involved in, right? And I'm being partly facetious, but of course there's an end-to-end system security that has to be considered in this whole picture. And whether you can achieve, the performance and cost and all the other metrics that go into any system in QKD, I think is an open question, but I bet there are people who would make a very compelling case for it. But I suspect that certainly the post-quantum cryptography, which doesn't rely on any quantum mechanical component, will be deployed.
I've heard conversations about people saying it's going to be quantum safe enough. That's kind of all back to your humans involved, concept. It's like as close as we can get. But so to your earlier point, let's talk about advantages. So what kinds of new products or services or, value creation opportunities could be represented in financial services for, quantum technologies?
Well, I think it's, to Ilias's point, that this industry hasn't lent in as much as others. And that surprises me, because I think this is an industry that has adopted technology and invested early in technology historically, whether it's, microwave links, optical fibers, high performance compute, you name it, right? And understandably so, because it's an industry where only it's often only a small edge that's required, unlike many other industries where, you want a sizable competitive advantage, right? Like if you're going to make the investment, obviously this is an industry where, a small edge in terms of, speed or accuracy, or et cetera, of solution can matter. And I actually think that, I always think about the financial services industry in general as in the context of quantum computing, where I kind of have this cartoon in my head of a Wall Street firm in the 1960s where someone dragged a rudimentary computer in and all the colleagues said, "What are you doing playing around with that rubbish? Get it out of here, like we've got real work to do here." And we don't know anything about that firm anymore because they just ceased to exist, right? And I think that's the sort of wholesale disruption, transformation that quantum computing promises across a multitude of industries. Now, whether it's as profound as that in the financial services and financial industry more broadly is an open question. But I think what's not an open question to the conversation at the start of this panel is that it's going to have a really, really big impact, right?
Yeah.
And so I guess the question is, what is that impact and when is it coming? And I think the answer to the second question is it's coming a lot sooner than you all might think. And so the answer to the second question, we don't have the full spectrum of the impact, right? Like at the moment,
right.
All of your folk, with PhDs in mathematics and computer science who would play around with this, they don't have access to the technology to start playing around with it. We have some pretty compelling, and all of us, I think, have mentioned this example of derivative pricing that Goldman Sachs have got a recipe. Like here's how you would use a very large scale quantum computer to tackle that problem. And I think there's that sort of thing. It requires real work, and it requires real work from people who understand how their own industry works and understand how people who understand how quantum computing works. And so Ilias will have plenty of examples as well. But in the normal mode of operation for an organization like ours, that means computational chemists at Mitsubishi Chemical sitting down with quantum applications engineers and doing what my co-founder Pete calls their homework, right? Which the hard math, write the code, figure out the resources required. How big a quantum computer do you need? How many qubits and how many computational steps? Iterate that process and so on. That's the work that needs to really happen now in order for any industry and any organization to be ready for this technology when it comes online.
Yeah. Kati, from an investment perspective, are you seeing people using quantum to create value in financial services?
We do, but
settings?
let me put some wild thought,
because I was tell us the names.
the names. But let me put some wild thought here, and many of you might disagree with me, but we are looking at the industry that is very keen on innovation, banking, but that runs for 70% on mainframes. Okay? So I'm putting very wild thought, and it's just a dream, maybe.
Go for it.
But I want to,
I'm an ex-IBMer, so I'm a fan.
You're
Big
a fan,
iron,
okay.
yeah.
But one of the reasons mainframes are used is the speed of analytics. If you want to run millions of transactions per second, there is no classical machine, no cloud that can do it today. This is why airlines are optimizing routing on mainframes. This is why banking is optimizing a lot of things on the mainframes. So now quantum computing is promising to speed up those optimizations. quantum computing is offering a solution to suddenly make it much faster and much more feasible, where you actually don't need to cut routes for optimization, but you can actually optimize on the whole set of data. So what if we just put a wild thought? What if we could replace some of these very big mainframes because of innovation, because we need a more secure, more future-proof solution with quantum machines, let's say within 10 to 20 years' time? How big is this opportunity? I think it's enormous, right? Yeah. And we are just talking about few use cases here, whether it's optimization of portfolio, derivative optimization, risk calculation, and so on. So I think it's great. And we see already today companies working on this. Of course, we don't see this at scale yet. It's a very early stage industry. But the early results that are demonstrated, we see real hedge funds using solutions, software solutions, to optimize their portfolios already today. They say, well, as soon as our matrix is more than 16 by 16, we are stuck. We cannot use classical machines. So we need to go somewhere else. So this is, for me, is already a proof that actually it's working and it's coming.
Yeah. Ilias, any phantasmagoric take on new products and services to quantum drive and
not really, no. I think perhaps to make this of a little bit more meaning, I mean, everybody in this room has got family, they've got kids, they care about things other than banking. I mean, what I would say is that in 1,000 years' time or 300 years' time, when the histories are written of the 21st century, which is a century of quantum, nobody's going to give a flying fuck about, you know. No, they're not. They're not. They're going to talk about how we improved humanity.
Yeah. And
what does that mean? You know, things that are safe for us to use, and Jeremy and others speak very eloquently about this, and I think that's really important to point out here. I think that computational biology, the creation of materials that allow us to live better and longer, to be kinder and more compassionate to each other, and have lives that are meaningful, these are the things that the history books will write about, and that is why quantum matters to every single one of us. It's why Satya Nadella said what he said, and Angela Merkel said what they said. There's an existential risk to organizations who don't adopt this, and countries. I mean, my contribution to this would be to point you to Jamie Dimon, who's, sanctified in your industry. Rightly so. And I've spent lots and lots of time with him. And he has 80 people who are doing nothing but quantum, 80. And he was a customer of our hardware 3.5 years ago, when our hardware did less than your iPhone does when you try and add things up. And why is that the case? It is because they fundamentally believe that every single aspect of JP Morgan's business will be profoundly impacted. And I'm telling you what is in the public record. So whether it's optimization, whether it's Monte Carlo integration, whether it's option pricing, whether it's fraud detection, whether it's being fairer and more diverse in the decisions you make about the credit you extend, right? These things matter. And so they're just the leader in this way. I mean, the other point I would make, which, again, you know, like I said, we're all human beings. We live, we eat. Some of us might not be feeling so well. We're much more focused on those things, which will have an impact on all of the clients that you guys have. Like, you don't just make money. You make money because you've got clients, and their lives will be impacted. And it is that impact that I would highlight, as opposed to some obscure thing. I disagree very much with Ekaterina, who keeps on saying 10 to 20 years. I don't know where you've been. I'm not in 10 to 20 years at all. I think Jeremy and I were on a platform the other day, and I think Jeremy and I both said that we'll be delivering, whatever, it doesn't matter what the numbers are, but something that makes a difference to organizations' lives within this century. And this scale of ambition, we're the only two firms, I mean, he's raised about £1 billion, and I've raised about £1 billion. We're the only two firms of any scale who have got real, proper customers. Like, none of this other stuff is out there. So I think I'd be very cautious before I start jumping it. And McKinsey, what the hell do they know? They get more things wrong than they get right. I hope there's nobody from McKinsey here, but most of what they say has been provably wrong. So let's take more control of what it is that we're in charge of. The United Kingdom, the United States, Australia, to name three because they all write in the English language, and that's my native language, have got national quantum computing programs. It's one click away. They are deep and meaningful reviews of what we're doing and why we're doing it, whether it's sensing, whether it's computational biology, making chromosomes that allow us to enjoy the lives that God's given us. These are the things that matter. Now, we can toss off on this other stuff, but honestly, it's not that relevant in the short term. That's my take. And I'm sorry, Katrina, 10, 20 years ago, I don't know where you're at.
Well,
I mean, Jeremy spoke very, very, very well.
I think she means on the the mainframe replacement.
Exactly. So I was saying that that at some point we are seeing these machines being already used in the industry.
But did you see what Microsoft, Jason Sanders, said yesterday? Did you read that? I mean, that's a GPT moment. Maybe not a GPT moment. We're going off track here, so I'll stop.
But so I want to sort of shift gears, go from waxing philosophic.
That's not philosophic.
Well, I mean, I totally agree that the quantum is going to change how we live and make the lives of our kids and grandchildren better, and make the personal
and our lives.
And on.
I'm only 62. I've got another 100 years yet.
Yeah, no, all that. It's all good. But again, just to provide some, I want to switch gears and get into some granular sort of in the weeds conversation just for a moment, down into sort of the NISC era conversation, right? Noisy intermediate scale quantum, right? Which is kind of where we are. Although there's talk more and more of us moving out of that era into fault-tolerant, error-corrected applications, right? So I want to get your take on what the implications are as we move into that space. Jeremy, you want to start?
Sure, yeah. So, I mean, definition, so NISC is just is jargon for, well, it's an acronym for Noisy Intermediate Scale Quantum, which is jargon for small noisy systems, and that's what we have today. So Ilias mentioned Google demonstrated quantum supremacy in 2019 with 53 qubits, and quantum supremacy is some more jargon for outperforming a conventional computer, and that's a pretty compelling scientific accomplishment. A chip the size of your thumbnail does something that a building scale billion-dollar supercomputer cannot do. As a quantum computer, it doesn't have any commercial value in that you can't run algorithms of a scale in terms of the width and depth, so the number of qubits and the number of computational steps. But nevertheless, the world has been very optimistic, I would say, for the last 10 years about the hope of finding commercial utility in terms of quantum algorithms and quantum computing applications in that regime. And now I think the consensus is fairly well settled that actually you need to be in the million qubit regime in this fault-tolerant, error-corrected utility scale. These are all synonymous. I didn't get the memo that swearing was allowed on.
Oh, sorry.
I'll follow
Only
suit.
Ilias, I think, got
that's
that.
That's a bleeping big quantum computer as compared to the small ones that we have today. And the implications of that. So there's been this kind of, I would say, unwarranted enthusiasm for these small noisy systems, and could we do something commercially useful with them? So the real action, I think it's actually always been clear, is in this million qubit error-corrected regime. And the implication of that is, to what Ilias said, is that this is big, expensive stuff, right? Like, this is why you're seeing nation states making big investments. So, in our case, Australia invested $1 billion Australian in us building the first utility scale system down there. It's not a program for the faint of heart to get into, right? It's not a couple kids in their basement, writing some code, right? Like, it's a big bit of infrastructure, and I think that's the awakening that's happening in the world. And Ilias has mentioned, English-speaking countries, but also plenty of others. And I think, typified by DARPA, who've been, for several years leading a utility scale, running a utility scale quantum computing program, which is very focused on, or which is exclusively focused on that goal, utility. I think it's a slightly strange field, quantum computing, where you have to insert the word utility in there, because we would assume that it would have some utility, otherwise we wouldn't be talking about it. But that has not been the case historically, and I want to highlight just why this is a challenging field. So you've got this NISC business, you've got this fault-tolerant utility scale business, you've got all this other jargon that we talked about before, and then to pile on top of that, you could read a newspaper headline from 8-9 years ago that said that Volkswagen are using a quantum computer to do route planning at Mobile World Congress in Barcelona. To which you should just think, wow, so it's here already, because your human brain can't stop itself from inserting the word, with some, faster or better or, with some advantage, right? No. Millions, if not trillions of times worse than you can do on your wristwatch. It's a proof of principle demonstration. So the headline is absolutely true, and I think that this is the awakening that the world, I think I hope, is that, yeah, it's got to do something better than can otherwise be done, and that's when you get to unlock whatever the number is, believe McKinsey or not, but huge amounts of value. And to Ilias's point, I totally concur with him. Much more interestingly than the money that's unlocked is the impact that this will have. Yeah. And, we face some pretty grand challenges today, and I'd sort of rank order them, climate, healthcare, energy production, agriculture, something like that. And you could not get a more profoundly powerful tool for tackling those challenges than a quantum computer. And that's why you're going to see, huge value created and a wholesale upending of industries. But first and foremost, and again to the opportunity and the threat is in irrelevance compared to the upside. Like, yeah, get on and fix some security loopholes, and at the same time get on with deploying this technology as swiftly as possible, like getting ready to deploy it for all of these really important applications that are out there.
So I just want to say, so we all are in agreement that quantum is super important for our future and for existence and so on. As an investor, I'm super worried if only governments would support development of these technologies. We have published a report with Lakestar, IQM, and the Quantum Insider, where it's very clear the data point, actually the private investment in quantum computing has fallen by 50%. The government has increased, and Europe is by far, so in the US actually there was a larger decrease than in Europe. Anyway, for us as private investors is a problem. Why? Because governments have changing priorities, and you cannot just depend on governments to develop the future of technology. So for us, saying that, I understand your point that, we are speculating, saying 10 to 20 years, we are speculating about value, but we all agree that it's important. So how do we communicate to private investors that it's worth investing today?
Well, I totally agree with you on that point, right? And, of course, we can't, we should be able to do this in a, given the upside, we should be able to do this in a purely commercial fashion, and I think that is indeed possible. In our case, we have enjoyed defraying some of the capital costs with government support, but just to emphasize that in that transaction, we are selling no quantum computers and no time on quantum, we're still a purely commercial organization. But I do think that, just as a straying back into philosophy, I do think that, increasingly the world's grand challenges are best met in, collaboration between all the constituents. I think governments have an important role to play in ecosystems, and Ilias can speak to this as well.
I wanted to address that last point that Katerina made. I think yesterday was a tipping point, literally yesterday.
Really?
And I'll tell you why. This is an AI conference. There has been a narrative, it doesn't matter whether it's NISC or not, there's been a narrative about what it would take for a quantum processor to have impact on the world. Let's forget about words like commercial, utility, whatever. We all use things because they have an impact. We use an hammer, we use an electric machine, we use our computers. And about a year ago, just over a year ago, we published a paper. We have a quantum computer that did something which created a state of matter. It doesn't matter what that state of matter was, but it was something rather interesting. And people at Microsoft, who already were our customers, said, hang on a minute, if you can do that, then we ought to be able to do X, Y, Z. Yesterday, there was an announcement by Microsoft. It's in the public domain. It's a 7-minute read. Jason Zander, important person at Microsoft. If you follow the history of OpenAI, you know who Jason Zander is. And they created a generative AI system for chemistry, generative chemistry. I don't know how many billions they spent on it, but they spent a year on it. They came to me, we sat down last June, and so they described this system, and they say quantum supercomputing system, which is made up of high-performance compute, these beloved mainframes, generative AI, and a quantum processor. And they believe that these three things together will change the world. And what did they do? Yesterday, they published details of how a generative system, this ChemGen system, plugged into our computer, came up with things that we humans could never dream of. It's not because we're bad people that we think that you need X number of qubits and Y levels of... We just don't know any different. That's the way, that's the groove that we're in. And just as generative AI is changing many other predispositions, it suddenly changed the predisposition for chemistry. Now, this is a big deal. It is a very, very, very big deal, and it's out there in the public domain. And I think that, therefore, we will start changing our opinions about what constitutes utility, if we use that word. And we will change our opinions, not because somebody like McKinsey told us, but because in our businesses, those of us who have the capacity and who are brave enough to use it, and who was Microsoft's client? It weren't a bank, it was Unilever.
Right.
And they'd been working on it for another year. And our computer was sitting at the heart of it, and soon it'll be Jeremy's computer. And actually, I don't think there'll be that many computers. There'll only be 3 or 4. So if you think NVIDIA's expensive at $3 trillion, wait until the quantum computing company's out there. And so I think these are today, and I would strongly encourage you lot who are here for AI to just think about that. This, I'll give it to young Luke here, and he can disseminate it to all of you, because he won't give me your email addresses. So I'll send it to Luke, and he'll send it to you. So it's a compelling read. It really is. And it's got all the references as well, in terms of what you look for. And these boys have done it before, right? Microsoft have form, if you like, in this area.
Yeah. So thank you. We've come to the end of our allotted time, but I want to close by asking each of you to share your take, advice, maybe one piece of advice for the audience members who, working in financial services, how to adopt quantum, how to explore it. Is it tied to talent or investment or executive support or partnerships, relationships with vendors, government support? I know, Jeremy, you mentioned your recent award from the Australian government. So what would you say if people are scratching their heads about how do we get into this? How do we enable and take advantage of this emerging technology? Katya, you want to go first?
Well, if it would be for me, I would suggest start with even hiring or creating a role like a chief quantum computing officer, and start creating a strategy how to live in the new world with quantum, because it's a big change. It's a cultural change. Even we are talking about education to be changed, actually, to work with these new technologies. So organization need to start thinking, how do I change? And to your point as well, like Unilevers of the world are already thinking, so it's a good example. So we need to start early on and develop this as the technology develops, so it's not taking us with a surprise later on.
Yeah. Jeremy, what would be your advice to get started? Where do you begin?
Well, the way I see it is that this industry, like pretty well every other, is soon to bifurcate into those that have access to and know how to use a quantum computer, and those that don't. And you don't want to be amongst those that don't.
It sounds like you're going out of business strategy on some level.
Yeah, and so I think, making sure you have access to both the capacity and also teams of people, either internal or external, who understand how to write fault-tolerant quantum computing software.
Great. Ilias, last word.
I couldn't possibly add any more, thank you.
No, really. One bit of advice for...
Talk to your biggest customers, especially those that matter.
Yeah. Okay. Should we take questions? Do we have time for a couple of questions? I know we're standing between you and an adult beverage, I think. But yes. Actually, someone in the back. Let's start with the gentleman in the back. Please stand up, tell us your name.
Hi, Ian Glasner, HSBC. Simple question for the three of you. If you found yourself running a financial services institution today and you had $100 to allocate to the defensive side of quantum and all of the exciting offensive ideas that you spoke about, how would you allocate the money today, and how would you see it shifting over time?
Allocate to protect, like deal with the harvest now, decrypt later threat? Is that what you're saying?
Exactly, right? So harvest now, decrypt later, PQD, right? And then the portfolio optimization and other more offensive types of ideas that you mentioned as well.
Yeah. Who wants to field that? Jeremy, you're shaking your head. Any guidance around?
Well, let's call it 50-50 for argument's sake, because if you get either of them wrong, you don't have a business anymore. So you got to get them both right, and you got to get them both right on similar sort of time frames, I'd say. So
same 50-50 today and 50-50 5 years from now?
I think in 5 years you can put it all on the you've got to have solved the threat by that stage, right? Like you've got to secure your networks on that time frame.
Yeah. Other questions?
Just wanted to make a comment, and first on Christopher Sachs. He's got quantum circuits for Sachs, so
sweet.
Very, very cool. I really like your quantum circuits. You guys talked about a fault-tolerant computer, right? And there's a lot of work going on in the error correction side. Could the industry work together on error correction, or is it just based on modalities? And can you guys work together in the industry, or is it every man for himself?
It is working together across industry and academia. So we, for example, have published a whole host of our error correction, fault tolerance work. It's ongoing research in universities. Other organizations are doing the same thing. And you imagine it's like any stack, right? Like abstracts as you get higher up, and so all of the stuff at the top is transferable and applicable across the board. And then as you get closer to the metal, you differentiate.
Can you give me a date?
A date?
Fault-tolerant computer?
2027.
2037. Yeah. All right.
No, we were on the same panel last week. We said the same date.
Both
Yeah.
of you guys are, okay.
Yeah.
Thank
All
you.
right. So we've come to the end. I want to thank Ilias and Jeremy and Ekaterina, and thank you all for listening. And connect with all of them on LinkedIn. Follow their companies. There's a robust quantum community on LinkedIn, a conversation going on. Learn more about what's going on in the space. So thank you, ladies and gentlemen.